4.6 billion years ago, the space you are currently sitting in didn't look like much. In fact, it was almost perfectly empty. This was the Presolar Nebula. A giant, cold cloud of gas and dust, stretching across several light-years of void. It was mostly hydrogen and helium, leftovers from the Big Bang, with a tiny sprinkle of dust from stars that died long ago. For millions of years, this cloud did absolutely nothing. It was in a perfect stalemate. Fact. To give you an idea of the scale, this cloud was thousands of times larger than our entire solar system is today. Gravity wanted to pull the cloud together, but the internal pressure of the gas kept pushing back. A cosmic tug-of-war. Without a massive shove, this cloud would have stayed a cloud forever. No Sunday. No Earth. No you. But nearby, a massive star, much bigger than our Sun, was reaching the end of its life. This star was a fusion factory, forging elements like iron and nickel in its core. But it was running out of fuel. When the fuel ran out, gravity won. The star collapsed in on itself in a fraction of a second. And then, boom! A supernova. One of the most violent events in the known universe. Fact. The shockwave traveled across the void at millions of kilometers per hour, carrying radioactive dust and immense energy. The quiet, sleepy Presolar Nebula had no idea what was about to hit it. Its long nap was about to end. This is the trigger hypothesis. The idea that our solar system was jump-started by the death of another star. Hypothesis. The pressure was about to become too much. The tug-of-war was over. The collapse was beginning. The supernova's shockwave didn't just pass by, it slammed into our cloud with the force of 1 trillion nuclear bombs. This big squeeze broke the stalemate between gravity and pressure. Gravity finally won. It also injected something special, radioactive isotopes like aluminum-26, the heat engines for future planets. As the cloud collapsed, it began to spin. Faster, and faster, and faster. A frost line appeared. Inside, it was too hot for ice to exist. Outside, it was a winter wonderland. Like a figure skater pulling their arms in, the shrinking cloud spun faster due to the conservation of angular momentum. Fact. Centrifugal force pushed the edges out, flattening the giant cloud into a thin, spinning pancake. Welcome to the protoplanetary disk. This pancake of dust and gas was the construction site for everything you know. 99.8% of all the material in the cloud rushed to the center, creating a massive, hot ball of gas, the protosun. In the remaining 0.2% of the disk, tiny dust grains began to bump into each other. This is where the magic happens. At first, it wasn't gravity, but static electricity, like a sock sticking to your shirt, that held them together. These dust bunnies grew into pebbles, then rocks, then boulders. A process called accretion. Fact. Once they reached a few kilometers in size, gravity took over. They became planetesimals, hungry planet seeds. Thousands of these seeds raced around the protosun, colliding and merging until only a few dozen protoplanets remained. The stage was set for a final, violent showdown to decide which planets would survive. And things were about to get messy. The supernova shockwave didn't just pass through, it acted like a giant cosmic piston, squeezing the gas until it reached a tipping point. In physics, we call this the gene's instability. Once the cloud gets dense enough, gravity becomes stronger than the gas pressure. Theory. Suddenly, the stalemate was over. The cloud lost its battle against gravity and began an unstoppable collapse. As the cloud shrank, something amazing happened. It started to spin. Faster, and faster, and faster. Conservation of angular momentum forced the spinning cloud to flatten out into a giant, cosmic pancake. Fact: this is the protoplanetary disk. This thin sheet of fire and dust is the construction site for all future planets. Near the center, it was incredibly hot. Thousands of degrees. Only rocks and metals could survive here. But further out, it was a frozen wasteland. This was the frost line, the border between fire and ice. This temperature gap is why the solar system is split in two: rocky planets inside, gas giants outside. Fact: 99.8% of all the material in the cloud was now rushing into the center, forming the protosun. We know this happened because we can see it happening right now in other parts of the galaxy. Fact: inside our disk, microscopic dust grains, the ash of dead stars, began to bump into each other. They were held together by static electricity, the same force that makes a balloon stick to your hair. Slowly, these dust bunnies grew into pebbles, then boulders. A process called accretion. How do we know a supernova was our cosmic parent? Scientists found a smoking gun inside ancient space rocks. Hidden in meteorites like Allende are traces of aluminum-26. This isotope only forms in the heart of massive stars. Fact: but Al-26 decays quickly. To be in our nebula, the supernova had to happen just as the cloud was collapsing. While the detective work continues, the center of the disk was becoming a monster. Gravity was crushing gas into a tight ball. Temperatures climbed to 15 million degrees Celsius. The pressure was so high, atoms could no longer stay apart. Fact: hydrogen atoms were forced together, fusing into helium and releasing a massive burst of energy. Ignition. Fact: in a flash, the protosun became a true star. Our sun was born. The infant sun was a messy teenager. It released a violent solar wind, clearing the leftover gas from the inner system. Only the rocky materials could stay behind. This is why the inner planets, including Earth, are solid ground. Fact: further out, the gas giants like Jupiter and Saturn grew huge, gobbling up the hydrogen the sun didn't take. This was the grand plan: a central star, rocky neighbors, and gaseous giants. But the drama wasn't over yet. Billions of years ago, a planet the size of Mars, named Theia, set its sights on a collision course with early Earth. Theory: the impact was world-shattering. It tilted Earth's axis and sent a mountain of debris into orbit. That debris eventually clumped together to form our moon. Without that supernova nudge, the moon wouldn't be here. The death of a star billions of years ago didn't just create the Sunday, it created the ground beneath your feet. With the sun born, you'd think things would settle down. But the solar system was about to go through a midlife crisis. Meet young Jupiter. It was so massive and so hungry that it started spiraling inward, toward the sun. Theory: this was a disaster. Jupiter was acting like a cosmic wrecking ball, scattering asteroids and protoplanets like bowling pins. Jupiter's migration is the reason Mars is so small. It stole the material Mars needed to grow into a giant. Theory: but then, Jupiter's little brother Saturn caught up. Their combined gravity created a cosmic tug. This is the grand tack. Like a ship tacking against the wind, Jupiter reversed course and headed back out. Theory: this U-turn saved the inner planets from being swallowed by the sun. It left Earth with enough space to thrive. But wait, there's more. Thousands of years later, another shuffle happened. The nice model. Theory: According to some models, Neptune and Uranus may have actually swapped places, throwing millions of comets into the inner system. This was the Late Heavy Bombardment. A rain of fire and ice that lasted for millions of years. Theory. This might sound bad, but those comets were rich in water. They may have delivered the very oceans we swim in today. So, thank Jupiter for the space. And thank the comets for the pool. Destruction and life are two sides of the same coin. After millions of years of chaos, the solar system finally reached a state of relative peace. The 8 planets were in their places. It all started with a death, a supernova that happened billions of years ago. A cosmic push that made everything possible. So next time you look at the stars, remember, you are the legacy of a star that died so you could live. After the chaos, the Sun entered its long middle age. For the last 4 billion years, it's been remarkably stable. But inside, it's anything but quiet. The Sun is a balancing act between the crush of gravity and the explosion of fusion. Every second, the Sun turns 600 million tons of hydrogen into helium. That's enough energy to power Earth for millions of years. Fact. A photon born in the core can take 100,000 years just to reach the surface. It's a long, crowded journey. Theory. Once at the surface, we see sunspots, cool, dark patches where magnetic fields are twisted tight. Fact. The Sun isn't a solid ball, its equator spins faster than its poles, tangling its magnetic field like a ball of yarn. When those lines snap, they release a solar flare. A sudden burst of X-rays and energy that can reach Earth in minutes. These flares can knock out satellites and radio communications. Even your GPS relies on the Sun's good behavior. Fact. How do we know what the Sun is made of? We look at its light through a prism. Its Fraunhofer lines tell the story. Spacecraft like SOHO and the Parker Solar Probe are our solar sentinels, watching the Sun 24/7. Fact. The Parker Solar Probe is touching the Sun, flying closer than any mission in history to solve the mystery of the corona. The Sun has been our steady companion for a long time. But no star lasts forever. Fact. In 5 billion years, our Sun will run out of hydrogen fuel. It will swell into a red giant, swallowing the inner planets. Eventually, it will shed its outer layers, leaving behind a glowing white dwarf, a diamond-hard core the size of Earth. The atoms from our Sun will drift back into space, becoming the seeds for the next generation of stars. The cycle repeats. So, our solar system had a violent start. But is our neighborhood unique? Or is this just how the universe builds homes? Our Milky Way has at least 100 billion stars. And for a long time, we thought our planet-filled system was a rare fluke. History. But thanks to missions like Kepler and TESS, we now know that planets are everywhere. Most stars have at least one. Fact. We find them by watching a star's light. When a planet passes in front, the light dips, like a cosmic eclipse. Fact. We found hot Jupiters, gas giants so close to their stars that they're being cooked alive. Fact. And water worlds, planets with oceans hundreds of kilometers deep, with no land in sight. Hypothesis. There are even planets where it rains rocks or glass, and others covered in endless oceans of lava. Fact. But the real prize is the Goldilocks zone, the perfect distance from a star where life as we know it could exist. Fact. Systems like TRAPPIST-1 have 7 Earth-sized planets huddled around a tiny red star. Fact. Every one of these billions of worlds has its own unique history, some born from supernovas, others in quieter corners. With the James Webb Space Telescope, we are now sniffing the atmospheres of these worlds to look for the building blocks of life. Fact. The Drake equation tries to estimate how many civilizations might be out there. The numbers are staggering. Theory. But if planets are so common, where is everyone? This is the Fermi paradox. Hypothesis. Whether we are alone or in a crowded universe, the story of our birth shows that destruction is just the precursor to creation. A star had to die for you to be here. Its death was our beginning. Everything we've talked about, the supernova, the collapsing cloud, the spinning disk, it's not just out there. It's in here. The iron in your blood, the calcium in your teeth, and the gold in your jewelry were all forged in the hearts of dying stars. Fact. You are quite literally a walking, talking piece of the universe. We are the way the cosmos knows itself. Philosophy. In the 13.8 billion year history of the universe, our entire existence is just a blink of an eye. Fact. From out here, everything we've ever known, every war, every love, every discovery, happens on a tiny blue dot. Philosophy. Our story began with a supernova, a moment of utter destruction that planted the seeds for life. And one day, our sun will return its atoms to the stars, continuing the cycle for the next world. Theory. This knowledge is our greatest treasure. It reminds us that we are part of something much bigger than ourselves. So next time you look up at the night sky, don't just see dots of light. See your ancestors. See your future. We are stardust, brought to life by the death of a star. And that is the most beautiful story ever told.